All right, today is completing the square. We are going to be solving by completing the square. The good news is you already have all of the tools you need to solve by completing the square. To solve by completing the square, we are going to combine the skills that we learned with writing an equation in vertex form with the skills we learned on how to solve an equation using radicals. We're going to use those two ideas and we're going to put them together. So we're going to review those skills since they're going to be so necessary for today's lesson. First, when we are taking the equation from standard form to vertex form, the whole completing the square process. To complete the square, you keep the x squared and the x term together. We ignore everything else. And what I think is the most important step is to set up your equation for completing the square. When you complete the square, you can only complete it when this is a 1x squared. So we're going to pull that 2 out. So that becomes x squared plus 7x. You have to pull the 2 from both of those pieces. Right? And now we are leaving this space here because this is the whole completing the square. We are completing it so that we get a perfect square trinomial. This is the goal right here. We want a perfect square trinomial. Now this is a little bit of a harder one. We know the process is half the middle. 3 halves or 7 halves, that's 3 1/2. We can't simplify that and we square it. 7 squared is 49. 2 squared is 4. So then I'm going to add that to the other side, but we got to be careful because remember we pulled that GCF out. So I didn't just add 49 over 4 over here. I added that twice. To keep my equation in balance, I've got to make sure that I multiply the 49 halves by 2 as well. So that 2 and that 2 cancel, so that becomes y plus 49 is equal to 2. Now remember, the whole point of doing this is to create this perfect square trinomial so that when I factor it, I get that same quantity twice. And normally you'd be looking at me like, okay, what 2 numbers to multiply to here and add to here? What? You want me to know what 2 numbers multiply to 49/4? Which normally, yes, I would be like, I'm crazy for asking you that. But because we did this, we know that it's always going to be half of that middle term. So this is x plus 7 halves quantity squared minus 1. That's my binomial squared. And then to get it into vertex form, I just need to move over that 49. And I get y equals 2, parentheses x plus 7 halves, quantity squared, minus, oh, you guys, I made a mistake. This was 49/4. Oh, you're so mad at me right now because you have to erase. So 49/4, the 2 goes into the 4 twice. So this becomes 49 halves. I move my 49 halves over, which gives me a negative 51 halves. Sorry. But what's important for this problem for vertex form is that process of completing the square. You complete the square with those 2, take half the middle and square it, add that to both sides. Then our other idea that we need is solving using radicals. And our goal is to isolate this quantity that's being squared. We move everything to their side. Minus 2. Negative 52. And then we divide by the 4 to get negative 13. We square root. And remember, the step that you square root is the step that you add in that plus or minus. The negative on the inside makes it an I on the outside. 13 cannot be broken down. To get x by itself, we move our 3 over. So again, today, our new information of solving by completing the square is a combination of those 2 review skills put into one. So completing the square is also going to be our last method of factoring. So we're going to look at all the different ways, or not the last method of factoring, the last method of solving a quadratic. So we're going to look at all the different methods of how to solve a quadratic. The very first one that we learned was factoring. And I would say that factoring is by far the easiest method, which you probably never would have thought that to yourself that you would prefer factoring over anything else. But yes, factoring is the easiest. The problem is not everything is factorable. So because if I try to multiply to 12 and add to 12, there's no two numbers that multiply to 12 and add to 12. That's always my go-to. That's the first thing I try. But it's not always going to work. So when that happens, we have other things to do. So can we factor? Oops. No. There's no two numbers that multiply to 12, oops, and add to 12. So then we think about all the different ways that we've learned. So we learned to factor. We learned square roots. Can we square root? Nope. Because x squared and the x term. So when we solve by square roots, we just had our x being squared. If we think about our ax squared plus bx plus c, when you solve by square roots, there's no bx term. In this case, we have a bx term, so therefore square roots is not going to be option. Can we use the quadratic formula? Yes. But we're not going to. We're not going to because we have a new method that we're going to learn, and that's solving by completing the square. The other method that I did not mention is graphing. Graphing sometimes works and sometimes doesn't. We know that it's only going to work when we have real solutions. It does not show what we have for imaginary solutions. Anyway, so we're going to go ahead and get started by completing the square. Remember, when we complete the square, we concentrate on the x squared and the x term. Everything else gets ignored. And the most important step is to get that equation set up. And to set it up, you need to make room for where you're adding that number to both sides. This is the number, this is what we're trying to do. We want to create that perfect square trinomial so that when I factor it, I have that same number twice. So we take half the middle, which is 6. 6 squared is 36. And if I add 36 to the left, I have to add 36 to the right to keep my equation in balance. When I go to factor this, the two numbers that multiply to 36 and add to 12, well, remember, we did this on purpose. It's 6 and 6. It's the same number twice. Doing that allowed me to go to x plus 6 quantity squared plus 12 equals 36. So remember I said this is a combination of vertex form and solving radicals. We just did the completing the square process that we learned from vertex form. And as soon as I do that completing the square, now I'm at solving by square roots. I move the 12 over. X plus 6 quantity squared equals 24. We square root each side. We break down 24, 2 and 12, 2 and 6, 2 and 3. A group of 2's with a 2 and a 3 left over. So this becomes x plus 6 is equal to plus or minus 2 root 6. 2 on the outside, a 2 and a 3 left over on the inside. You multiply the numbers together. We move that 6 over and we get x equals negative 6 plus or minus 2 root 6. So when you are thinking about all the different ways we have learned to solve a quadratic, we can always use the quadratic formula. That's never going to fail. Can we always use completing the square? Yes. The only two methods that always work are completing the square and quadratic formula. We know that graphing only works for real solutions. So sometimes things are factorable, sometimes they're not. Sometimes we have an x squared and an x, and if we have that, we can't do square roots. So out of all of the different 1, 2, 3, 4, 5 methods we've learned, only 2 of them are always going to work. All right, and completing the square from today is one of them. We are all done.